As we recall, an ionic bond is a bond between a metal and a nonmetal. So it is something on this side of the periodic table bonded to something on this side of the periodic table. And so far, up to this point, all of the metals that we've dealt with have been metals located in this region or this region. But we have this entire area of the periodic table that we've been skipping over. And that's what we're going to be dealing with now. These are called transition metals. They are the metals in between, in the D block, that are more or less in the middle of the periodic table. And these metals are special because they're a little bit funky. Sometimes they have one charge, sometimes they have another charge. We learned in prior videos that we can predict an element's charge by looking at what column it is under. So the first column can form a positive 1 charge. I'm going to do it in a different color. But first column can form a positive 1, second column positive 2, third column positive 3, no charges here, and then -3, -2, -1, no charges. And but we've been skipping this region right here. And these are the transition metals, and the reason why we've been skipping it is because they have the possibility of forming multiple different charges. It's a lot harder to predict the charges that transition metals will hold. And so we're going to talk about how to deal with that here in this video. So as I said, transition metals, a lot of them have multiple different charges. In fact, all of them except for 2 have multiple different charges that they can form. So the two exceptions are silver and zinc. And those only form one possible ion. But every other transition metal out there can form, and even some metals over here that aren't transition metals, they can form multiple different ions, or ions with multiple different charges. So we talked about before, up in these last videos, we talked about how we can always know, going from an element's name, we can always find the element's formula, just because, like, calcium always forms a positive 2 charge, and oxygen always forms a negative 2 charge. So we can always know that calcium oxide is CaO, because the only possibilities is for calcium to form a positive 2 charge and oxygen to form a negative 2 charge. But notice how this might be trickier if we have if calcium were to have the possibility of forming multiple different ions. Then we wouldn't know how many oxygens we would need. Maybe we would need more oxygens or fewer oxygens, etc. So the charges, the fact that these elements, all on over here in this first 2 columns of the periodic table, the fact that they always have predictable charges, and also maybe even this third column on the periodic table, since they always have predictable charges, we don't have to do any extra steps. But with transition metals, we do, and it's totally doable. It's not that difficult if we just follow along. But yes, so let's do some examples with these transition metals. So let's do our first example. Let's do manganese and fluorine. So let's look at a bond between manganese and fluorine. So, well, first of all, let's start with a name. So we have manganese and fluorine. The naming is going to be the same as any other ionic compound. We're going to have the name of the first element. There's slight differences. So manganese, we have the first element, and then we're going to have the name of the second element, except we're going to get rid of the ending and we're going to replace it with IDE. So we have manganese fluoride. However, the fact that manganese can form multiple different ions, or in other words, the fact that manganese can form ions with multiple different charges, we don't definitively know the charge of manganese just by saying manganese fluoride. We need to clarify that here in this region right here. And the reason why we do that is we might have manganese 2 fluoride, and that would look like this, where we would have manganese and 2 fluorines. Or what if we had manganese 4 fluoride? 1, 2, 3, 4. That's not how you do Roman numerals. 1, 2, like that. What if we had manganese 4 fluoride? Well, then we would have 4 fluorines. So notice that the charge that manganese holds is going to create a different compound. So I'm not sure if manganese 4 fluoride actually exists, so I'm just going to leave the first example. Manganese 2, oh gosh, my Roman numeral skills. Manganese 2 fluoride, we're just going to leave that one written here. But we now can see, we can start to understand the importance of these Roman numerals here, because they tell us they're going to make a big impact on what the compound is. So real quick, how did I know that this is manganese, the manganese 2 fluoride is MnF2? How did I get this 2 here? Well, I can say that if we know that the charge of manganese is positive 2, and we already know that fluorine, it is and always has been -1, I can do our crisscross method that we learned in the last video and say that we are going to have manganese 1, fluoride 2, but we don't write the 1. But notice if we had a different charge here, if we had manganese 4 fluoride, this would be a positive 4 written here, and then we'd write that there instead. And then we were going to have manganese fluoride with 4 fluorines. But we're writing it as manganese 2 fluoride. All right, let's do one more example, except let's do it backwards. Let's say we have we're going to do I'll do it in red. Let's do nickel and oxygen. And I will just tell you that the compound that's formed is going to look like this. And we want to figure out how to name this. Ni2O3. All right, so we have nickel, and nickel can form a positive 2 charge or a positive 3 charge. And we need to figure out which one it is. Well, we know that, if we're going to start off the name, the first word is always going to be the first element, so we have that. But we can also do our little cheat method down here and figure this out. So we have nickel, and we don't know what charge nickel has yet. So let me highlight that in green. We don't know the charge of nickel just yet. But we do know that oxygen has a -2 charge. It always has and always will have a -2 charge. Well, I'm going to write this -2. I'm going to move it and write right here. And then I'm going to take this, whatever this is, and write it right here. Or better yet, another way to approach this is I could do the opposite for what we have right here. I could take this 3 and move it right here. And I could take this 2 and move it right here. So we're going to get nickel with a +3 charge and oxygen with a -2 charge. So that's going to tell us that this 3 here that's the important thing. That's going to tell us that we have nickel with a +3 charge. So we're going to write that as Ni123 oxide. And again, it's nickel and oxygen, but we're going to drop the ending and replace it with IDE. All right, so there's 2 examples for us. Let me rewrite the problem for us. Ni2O3, just so it's easier to see. But there are 2 examples for us on how to do these. More examples will be included in some other videos, but this will kind of give us a sense of why we need to have these Roman numerals written for the transition metals. So hopefully this is helpful. Ask questions if you have any.